Good morning, guys. Hopefully everyone's doing well. If you can throw in some green checks in Blackboard. It looks like everybody's kind of moseying on into this Zoom video thing with relatively little problems. Is anybody running into anything that they want to let us know about? Last day, obviously, we ran out of space and there's hard drive issues, whatever. We're going to hopefully make it through today's lesson without any problems. So if you do run into anything with Zoom or like loading the video or things like that, where you have some issues, make sure you let us know so we can try to fix it and streamline the process a little bit. Eric, are you with us? And Joshua and Leeds. If we can get some green checks in Blackboard, just so I know we're doing okay. While those guys are finding their check mark, if you ran into any problems last day, we looked at slope-intercept form of a line, and that was section 4. If you ran into any issues on the learning guide or slope point, you want to go over anything there, let me know. So Leeds, I see you're typing in the chat in Zoom. The chat in Zoom isn't as good as the Blackboard chat, so we're not going to use the chat in Zoom. So we're going to use Blackboard. I know it's kind of confusing because Zoom does have the chat function, but we're going to try to not use it because it doesn't really allow us to do the same things Blackboard does. Eventually, it'd be really great if we had everything kind of all in one, but we're not there yet. So once we get there, we'll let you guys know. So if you had a question about the work from last day, can you throw it in Blackboard? And I have that chat going as well. And I can see my Blackboard chat, but I can't see the Zoom chat. So if you've written something in Zoom and it's important, you need to put it in Blackboard so I can have a peek at it. I don't see anybody typing in any questions. I don't have green check marks from Josh, and Leeds is now typing, so I assume you're with us there, Leeds. Any questions from last day? Kind of worries me when I come to class and you guys don't have any questions from the previous day, because that means to me that like nobody did the work, because you should definitely have questions. Just like before, Leeds, how do you talk in Blackboard and watch in Zoom? Before, when you went, you had your video playing. We used a different program to broadcast the video, though. It was using Lifesize instead of Zoom. So it's the same thing. You have to, you type just like you did in Blackboard, and then you have everything up in Zoom. But I see that Leeds is logged out of Zoom. So I'm just going to type her. Okay. All right. So again, Leeds, you just need to be in Zoom to see the video, and in the top right corner, there's a little thing that says gallery view, and then the 4 arrows, and then you can like adjust the size of the window. So just find a window size that works for you on your screen. You don't have to obviously have it giant sized or anything. Okay, I'm going to go through lesson 5. This is the last lesson for Unit 6. Now, one interesting thing about Unit 6 and Unit 7 is that Unit 6 and Unit 7 are both based on lines or linear functions. So once we finish Unit 6, you think, oh good, we're done lines, we don't have to deal with linear functions or anything anymore. Unfortunately, that's not the case. You are going to see more lines in Unit 7. There's only 3 sections in Unit 7, so it's a really, really short unit. And I know Jenna messaged me this morning asking me about the final exam, which is on the 25th. I'm going to go through that on Thursday's class because we have a longer block. So I'll do a bit of I'll get you some review material for the final, and I will also kind of talk about what it's going to look like, and then we'll start Unit 7. So kind of plugging away here. We'll finish Unit 7 at the beginning of next week, and then you'll have about a week for review for the final exam. So today's lesson is the 5th lesson in Unit 6, and it's on the general form of a line. So if I jump back to the formula sheet that you guys have, you can see that we had 3 different ways to represent a line here. The first one is slope-intercept. Oh, I thought I turned that off. The first one's slope-intercept form. The second one is standard form, which is what we're going to deal with today. So this is standard form. And then the last one is slope point form, which is what we looked at last day. So when you guys get into a test or the final exam for this unit, you need to be aware of the 3 different forms of a line. And on your formula sheet, they're all there, which is great. But they don't tell you which one's which, so you have to know which one's which. So let's jump into lesson 5 here, and this is the general form of a line. Ax plus by plus c is 0, where a, b, and c are just whole numbers. They have to be whole numbers. They can't be fractions. So this is really, really important. Can't have fractions. All right, I'm gonna jot down a few other rules over on the side here about standard or general form, I should say. So a, the first letter here, a can't be a fraction. It must be positive as well. So a must be positive. A must be positive. That's confusing. Generally speaking, we can have no fractions. For A, B, or C. What else? The equation must be equal to 0. So you always have to have equals 0. And the order matters. So it has to be a x, then b y, then c equals 0. So right now that's probably just a bunch of random letters. Let's kind of look at what this kind of means for us. So the first example, we've got a line here, y is -1/4 x plus 3. It's in slope-intercept form. And the question's asking us just convert it into general form. So what we need to do is just rearrange everything kind of algebraically to get the x term first, then the y term, and then a constant if there is one, and equals 0. And c doesn't always have to be a number. Sometimes c is, there is no c. Just depends on the line. So let's look at this. The first thing I notice is that I have this fraction 1/4, and I don't like dealing with fractions. So the first thing I want to do is just get rid of the fractions, because in general form here, you'll see that I can't have fractions, so why not get rid of the fractions? So what I'm going to do is I'm going to multiply each term by 4 to get rid of the fraction. And by doing that, kind of just sets me up for success. So I'm going to multiply everything by 4. And if I do it to one side, I have to do it to the other side. So on the left side, I'm going to have 4 times y is 4y. And on the right side, I'm going to distribute the 4, feed the chickens, distributive principle of multiplication. I'm going to distribute the 4 through. So a quarter, or negative a quarter times 4 is going to give me 1. And that's why I picked 4, because it was in the denominator. A quarter times 4 is 1. So I guess I could just rewrite it. 4 times negative a quarter, do it in 2 steps, plus 4 times 3. So I've multiplied everything by 4. Okay, 4y is just going to stay the same as 4y. Negative a quarter times 4 is going to give me, I forgot my x here. Negative a quarter times 4 is going to give me negative 1 times x, and then 4 times 3 is going to give me 12. Okay, now the idea here is to get everything into this general form. So I need my x term, then my y term, then a constant equals 0. So I want to just make everything equal to 0. So I'm going to have to move everything to one side. Either the left or the right, it doesn't matter. As long as everything's equal to 0, we're okay. But I need to remember that the a term, the thing in front of the x, has to be positive. So right now I have 4y equals negative x. It's negative. It's on the right side of my equal sign. I need to move it to the left side, and by moving it to the left side, it makes it positive. So that's why I want to move it to the left, because then it'll become positive. So what I'm going to do is I'm just rearranging everything. I'm going to add x to both sides. Oh my goodness. No, don't want that. I'm going to add x to both sides to get rid of it on the right. So I'm going to move it to the front. I'm going to get x, and then I had 4y over there already, and equals 12. And I'm just going to continue this over here. X plus 4y is 12. I'm getting closer to standard form, but I'm not there yet. I have to have equals 0 on the right side. So if I want to move that 12 over, I'm going to subtract 12 from both sides. And remember, the order is important. So x, then my y, and then minus 12 equals 0. Now, if I kind of compare this to ax plus by plus c is equal to 0, that general form, you can see that everything's good. You might notice that I have this negative 12 instead of plus c. That's okay. The only thing that's really important is that the first term, the x term, is positive. And in this case, it is. We don't have any negative numbers out front here. So that is how we convert from slope-intercept form into general form. And essentially, they're all exactly the same as that. Let's look at the next letter here. It's the exact same question. We're supposed to convert it into general form. And hopefully you can recognize that this question here is written in slope point form. So the first question, A, was in slope-intercept form, but now this is in slope point form. And remember, slope point form, you have your slope here, and your point is, we always call it P, is going to be whatever's behind the x and whatever's behind the y. Remembering that they need to both be negative. So this is going to be 4 and negative 2 is the point. So that's what we talked about last day. Has nothing to do with what we're doing today, but I just thought I'd mention it quickly. All right, we need to get this into standard form, or general form, I should say. The math can be done many different ways. Doesn't matter how you decide to do this. It's just a matter of doing it. So what I'm going to do is I'm going to multiply everything by 2. Why am I going to multiply everything by 2? Well, it gets rid of my fraction in my denominator here. So I can put it all in brackets and go times 2, or I could do left side, right side. In any event, I'm going to end up with 2y, I don't like this red. Let's change up our color here. I like blue. All right, 2y plus 4, and then 3 over 2 times 2 is going to give me 3 times x minus 4. The next thing I'm going to do is distribute my 3 through my brackets. BEDMAS tells me I have to do that. So I'm going to get 2y plus 4, and then I'm going to have 3x minus 12. Okay, I need to get everything to one side, and whatever's in front of the x, this number here, in this case it's a 3, this must be positive. So the 3 must be positive, and in order to keep it positive, I'm going to leave it on the right side. I'm going to move everything to the right side. So I'm going to subtract 2y from both sides. And that's going to cancel it there. Oh, I might just lose my mind on this computer today. All right, what did I have here? Plus 4 is equal to 3x minus 2y minus 12. So I just snuck the 2y in between the 3x and the 12 there. Now I'm going to subtract 4 from both sides. And you'll notice that I have something to combine the 4 with here. I have this 12, negative 12 minus 4. So I get 0 over here. 3x minus 2y minus 16. So then I check, is it in the form ax plus by plus c is 0? Sure, the 0 is kind of on the other side here. That doesn't really make too much of a difference. I can put the 0 on whatever side I want. In this case, the 3 is the a, the negative 2 is the b, and the negative 16 is the c. So it is, in fact, in general form. How are we doing? How we feel about that? Confusing, simple, pretty straightforward. When it all comes down to it, it's just algebra, right? Moving things around. And I guess not the trouble we run into is that there's just more than one way to do these types of questions. So you can multiply first and then move things second, or you can move things around and then multiply. And so you can run into different ways to do them, which I don't want to say confuses things, it just kind of allows you some freedom. Now, this one question example 2 here is kind of like a huge idea. It's kind of just snuck into this lesson. This is a really, really important idea that you'll use in math forevermore, if it's the next 2 years or if you go on to university or college or whatnot. X and Y intercepts are a very, very important idea. And I remember last year when I went through this online with the previous group, it was kind of, a lot of people kind of missed the whole idea. And I was just like, well, we did it, example 2, there it is. So I'm gonna stress how important this one is. I'll put a red star next to it. It's really simple, really basic, but for whatever reason, last year students had a real tough time with it. I don't know why. Hopefully you guys just look at it and be like, wow, that's really easy. Maybe by me telling you that this is a really important idea that comes up a lot and you'll use in math a lot, maybe you'll kind of wake up and pay attention right now. But this is a really quick way to graph a line. And if you have an equation that's in the form that we have today, so general form, you can use this to graph a line very quickly. And the math is very easy, and it's just a quick way to figure out what a line looks like. So if we have an equation in like y is mx plus b form, we have the slope, we have the y-intercept. I can say, okay, it crosses right here. I know my slope, so I can draw my line. You can draw a line really quickly if you have it in that form. If you have it in slope point form, not quite as easy. You might have a point, and then you say, okay, my slope is, -2, 3, and then or -2, 2, and then you draw your line. When you have something that's in general form, it's a little bit tricky to look at it and figure out what's going on. So just by looking at this equation, 3x plus 2y minus 18 equals 0, we can't just look at it and figure out what that line is going to look like. So we do need to do a little bit of math to kind of figure out where it's going to go, but the math is easy. Now, determine the x-intercept and determine the y-intercept. There'll be lots and lots of questions like this that you'll run into. This year, next year, if you go on in math into calculus, this is like such a hugely important idea. And it's really, really straightforward, I think. Once you kind of wrap your brain around it, it's really easy. So the x-intercept is where the line crosses this is our x-axis. So I want to figure out where our line, this equation, 3x plus 2y minus 18 equals 0, I want to figure out where it crosses that axis. If I can figure out where it crosses the x-axis, and then I can figure out where it crosses the y-axis. Let's say I figured it crossed right there. I did some math, okay, it crosses there, and then I figured out it crossed the axis there. Well, I have 2 points all of a sudden. So I can connect those 2 points with a line, and there you go, I've drawn my line. So if I can figure out where it crosses the x-axis, and then I can figure out where it crosses the y-axis, I can draw my line. Now, there's one very important thing about all points on the x-axis, this horizontal axis. And that is this. If I had a point, let's say just a random point, I'm just going to put a point right here. If I were to write the coordinates of that point, what would they be? So I figure, okay, I write my coordinates like this. I'm going to put my x term first, then my y. So I'm going to go over 1, 2, oh boy. Okay. Just going to reboot. One note here. And would you believe that my computer is special enough to have two OneNotes on it, and I have to open the right one? Oh my goodness. Cancel. Mr. Borden, have a new computer. It'll be great, they say. New computer will be fast, have great resolution, be amazing. I don't know that it's Windows 10. I turned off the touch, and then it turned itself back on, which is not exactly ideal when you're trying to use it. So I think it's user user error. All right, where was I? I was talking about this point, a random point. This has nothing to do with this question. We're just going to ignore the question for now. The point has an x and y intercept, and I need to figure out what the coordinates of the point are. So I go 1, 2, 3, 4, 5. So my x value is 5, and my y value is 0. All right, I'm going to put another point on this x-axis, and let's put this one over here. 5, 6, 7, 8, 9. So that's 9. Looks more like a G than a 9. 9, 0. I'm going to draw another point right here. That's -2, 0. Now, I've got 3 points on my x-axis. Do you, anyone who's awake out there in the world, can you see a similarity that's shared between all points that are on the x-axis? All points on the x-axis have something in common. I've drawn 3 here. What is something common to all points on the x-axis? Somebody's going to figure it out. They're on the horizontal axis. They all have a 0. That was what I was looking for, Jesse. And Leeds, thank you. The 0 goes in the y. Why? Y is always 0. That's amazing. So any point that's on the horizontal axis, the y value there is 0. I haven't gone above the x-axis or below to have a positive or a negative y value. So they all have 0 for y. That's pretty cool. All right, let's take that idea and let's see if that can be kind of extended a little bit further, because that's a really important point. Now let's take that same idea and look at the y-axis here. Let's take a random point, nothing to do with the question. What's my coordinates here? Pardon me. What are my coordinates? So I have 1, 2, 3, 4, 5, 6, 7. X is 0. My y value is 7. All right, let's pick another point. Let's do this guy right here. X is 0. Y is 2. And let's pick another point right here. That looks like x is 0, y is -2. All right. Now talking about the vertical axis, what is something common to all points on the vertical axis, the y-axis? What is shared by all of those? Hopefully you see where I'm going with this. Thank you, Leeds. The x value for any point on the y-axis is 0. So it doesn't matter where you go, as long as you're on the vertical axis, your x value is 0. You haven't gone to the right of it to give it a positive x value. You haven't gone to the left to give it a negative x value. All right. Whew. I'm going to a very extreme lengths here to prove my point on this stuff. Okay. When it says determine the x-intercept, determine the y-intercept. If I'm trying to find the x-intercept, let's say this line looks like this. I don't know what it looks like, but let's say it looks like that. If I'm trying to find the x-intercept, I'm trying to figure out where the line, this equation, crosses that x-axis. And I know on the x-axis, the y-coordinate, the y value is going to be 0. It has to be. So I'm going to use that to my advantage. Anytime someone asks you to determine the x-intercept of a line, what you need to do is you need to set y equal to 0 and solve for x. Okay. Let's see what this looks like. I have 3x plus 2y minus 18 equals 0. Now, I just said you need to, that was fun, set y equal to 0 and solve for x. So anywhere there's a y, I'm going to put in a 0. So I'm going to have 3x plus 2 times 0 minus 18 equals 0. And the reason this works is because I know that any value on the horizontal axis, the x-axis, has to have a 0 value for y. Remember that equation is just a line. That's what the equation is representing. And the reason this is really cool is because I am really good at multiplying by 0. I don't know if you guys have mastered your zeros times tables yet, but I am good at it most of the time. And I like things in math that are simple. So 2 times 0, just going to give me 0, which is kind of nice. And then I'm going to have, I could put in plus 0 if I wanted. I don't really need to. It just kind of goes away. So I'm just going to make it go away. So what I really have here is 3x minus 18 is equal to 0. All right. I'm trying to get x by itself. That's the second part of what I've written up here. Set y is equal to 0 and solve for x. Why, computer, must you be frustrating? All right. I'm going to add 18 to both sides to kind of get that x by itself. I'm trying to solve for x. So I'm going to add 18 to both sides. Didn't click there. 3x is equal to 18. And then I'm going to divide both sides by 3. And I'm going to end up with x is equal to 6. What does that mean? Well, that is my x-intercept. That means that when y is 0, x is equal to 6. And that's just an ordered pair, 6, 0. So what I can do is just go 1, 2, 3, 4, 5, 6. Boom. That's my x-intercept. That's where that line crosses the x-axis. Now, I'm going to do the exact same thing for my y-intercept now. It's the exact same process, except in this case, I don't want to make y equal to 0 and solve for x. I'm going to do the kind of the opposite of that. I'm going to, when I want to find the y-intercept, I'm going to set x equal to 0, because again, any point on this vertical axis has an x value of 0. I'm going to set x equals to 0 and solve for y. So we should be really good at this now. I'm going to rewrite my equation. 3x plus 2y minus 18 is 0. And I'm going to make x equal to 0. So I'm going to go 3 times 0, put in 0 for x. So 3 times 0 plus 2y is 18. All right. 3 times 0 just gives me 0. So I guess I could write 0 here, but I don't really need to. So I'm going to go 2y minus 18 is 0. And I'm trying to get y by itself. That's the second part here. Solve for y. So I'm going to add 18 to both sides. Minus 4 in Ottawa. Really important to know that. Okay. Plus 18. All right, so I have 2y. This 18 goes away, is equal to 18. And then I'm going to divide both sides by 2. And I'm going to end up with y is equal to 9. What does that mean? That means when x is 0, y is equal to 9. So I have another ordered pair, 0, 9. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. I launch Internet Explorer. After that's done, I count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. I put my point. So this is 0, 9. And I have 2 points which I can connect with a line. Use my trusty calculator ruler. That didn't work at all. Back to mouse. Well, that's not bad. Not bad at all. There you go. I have the equation of a line. So I can't really stress how important this concept is. It is very important, being able to find x and y intercepts. And it's really, really easy. You're putting 0 in for x, solve for y. You put 0 in for y, you solve for x. That gives you your x and y intercepts. Once you know where it crosses the x and y axis, you can draw 2 points, connect them with a line. You're done. So I think there's a bunch of questions in the learning guide on x and y intercepts. They refer to this kind of example here. It's a really important concept. I think I've said that enough times. Let's look at this last guy here and then set you guys free. Determine the slope of a line. This assignment, you can just ignore it. Refers to the textbook. I accidentally forgot to take it out. Determine the slope of a line with the equation. All right, so this equation is in general form. And when we have something in general form, we don't know what the slope is. So unfortunately, when we have an equation just in general form, you can look at it, but you can't just look at it and say, okay, the slope is 3/2. It just doesn't work that way. So what we need to do is rearrange the equation. So you can put it into slope point form or slope intercept form. It doesn't matter which one you do. I like going into slope intercept form. I just think it's easier. So we need to convert to slope intercept form. And that way we'll just be able to look at it and figure out what the slope is. All right, so we have 5x minus 2y plus 12 equals 0. When I have something in slope-intercept form, it's going to look like y is mx plus b. So I want to get y by itself. So if I'm going to convert into slope-intercept form, I need to isolate y, or get y by itself. So I'm going to do that. And in order to do that here, I could either move the 5x to the other side and then the 12 to the other side, or I could just move the 2y to the other side. And I'm going to always do the opposite. So if I'm adding 2y, or subtracting 2y, sorry, I'm going to add 2y. If I do it to one side, I have to do it to the other. So I'm going to have 5x, 2y goes away, plus 12 is equal to, and then I move this 2y over here. Now I'm trying to get y by itself still. So in order to do that, I will divide both sides by 2. If I do one term. I have to do all of the terms. So I get 5 over 2 times x. 12 divided by 2 is just 6, is y. That is in slope-intercept form. I could rewrite it as y is 5 over 2x plus 6, just switching the side the y's on. Doesn't really matter. In any event, I was interested in the slope. And if I have something that is in y is mx plus b form, whatever is in front of the x is the slope. So in this case, the slope is 5 over 2. Rise of 5, run of 2. Or we could call it m is 5 over 2. Because m is the letter we use to represent the slope. It's about 9:45. We're scheduled till 10:15 today. So what I'm going to do is I'm going to get Mr. Ross to put up a timer for about 15 minutes, I think. And I'm going to let you guys look at the learning guide for 15 minutes. It doesn't necessarily need to be from today's lesson. You could look at stuff from before, just anything from the learning guide. But just take 15 minutes to kind of browse through the learning guide, try a few questions, and then come back with any questions you have. Let's look at the learning guide here real quick, or a calendar. We could look at a calendar too, I guess. Finding equations of linear functions, so we've done that. Intercepts and equations, so this is kind of where we started today. This is the bottom of page 8. So if you want to look at some stuff that we looked at today, you can start at the bottom of page 8 and graph the equation using the x and y intercepts. There you go. So there's a couple pages of graphing intercepts and equations. This is page 8. So I'll give you guys 15 minutes. Have a look, try some questions. When we come back, I'll answer any questions you guys have. If you don't have any questions, we'll just sign off, and I'll see you guys next day. So 15 minutes. Have a look, and we'll see you in a few. Thanks. Hi guys, welcome back. Did anything come up? Any issues, troubles, things you didn't understand, questions you didn't get right? Anything you'd like me to go through? Just in general. Unit 6. Nothing. Anything? Nothing? Is my audio on? Can you hear me? You hear me, green check mark? Green check mark. Let's go with the green check. Yeah, Ian. All right, you can hear me. You guys are just so smart, so far behind, or we'll go smart. You're so smart, you got all this stuff just under control. Okay. So I see Jesse's typing, so I'll give him a second to finish his thought. You're all of the above. Really smart and far behind. I like it. So what we're going to do next day is we don't have a class tomorrow. You guys will be at the Cleveland Museum of Natural History to visit an entomologist. And he studies, I believe his specialty is praying mantis. I didn't read it, but one of the other teachers in our building told me about that. So we're going to look into his job, see what he does. I think it's going to be really cool. It'll be kind of like the one we did with the dinosaur bones and casting of bones and stuff. So that's tomorrow. Thursday, we are going to have a double block, so it's from 9 to like 11:30 or something like that. I would love it if you guys came with a bunch of questions from Unit 6, and I could do them for as long as it takes. But if you don't have any questions from Unit 6, I'm just going to start into Unit 7. And Unit 7 is only 3 sections long. And I don't think people generally find Unit 7 terribly difficult. So anywho, that's what next day is going to look like. As well on Thursday, I'm going to spend a few minutes just talking about the final exam, what it's going to look like. I'll give you guys some resources to practice with and some questions to look at and things like that. So that gives you about a week and a half to kind of start thinking about that final exam. So that'll be next day. And then basically next week we'll spend probably 1 or 2 classes finishing up Unit 7. And then we will spend the last couple classes reviewing for the final. And I always say this when we get to the end of a course, but reviewing isn't kind of up to me, it's up to you guys. You're going to get out of it what you put into it. If you just kind of like, I learned it already, you're not going to do so well. But if you put the time in and you start reviewing and thinking about the things that you don't know and starting to learn those, you should do fine. And I'm not concerned about any of you guys not doing well. So there you go. Thanks very much for coming today, and I will see you guys on Thursday, and we'll wrap up Unit 6, we'll start Unit 7, and we'll talk about the final exam. So have a great afternoon, and we'll see you on Thursday.